Good morning. This is Dr. Reveles with a minimization problem involving two functions. Let's start reading the problem. Breeder is buying two brands of food, A and B, for her animals, and each preparing a mixture which should have protein and fat. And we are aiming to find the minimum cost, so how we should combine A and B. Okay, first thing we did is, given all that information, extract that information to a table. See, I'm going to call brands A and B, which corresponds to X and Y, just because we are familiar with X and Y. And I make in this table cost, protein, and fat for each of them. Now, start solving the problem, we have some constraints. Let's go for our constraints. Constraints are such that our mixture should have a protein, which is a contribution of X and Y, which has to be greater than 40 grams. So what we did here is say, okay, total protein comes from 20x plus 10y, that will be the total protein. Then we can rearrange solving for y. Y has to be greater than 4 minus 2x. So let's do the same for fat. Total fat now equals 10x plus 10y. Now they tell us how to be at least 30 grams, greater or more than 30 grams. In this case, we're saying fat, 10 grams of fat comes from A, 10 grams of fat comes from B. Rearrange the equation, we have our second inequality, which is going to be y is greater or equal to 3 minus x. Okay, we're ready to the graph. So let's make the graph x and y. So and our graph tells us that this is y, this is x. So we want to graph these two functions. So we notice that the first function is a straight line with negative slope. I'm going to say that this is my first function, which is 4 see 4 minus 2x. So we are graphing out this function. Because it's greater or equal, I'm going to say this should be a dashed line, because our space of solution is above this line, greater or equal to this. Next function now is going to be another line, but now cross a tree. So this is my second function, which is going to be 3 minus x. So this is the second function in the graph. So because this has an equality, so this, we have really a space of solutions. So all the space here is the possible solutions for our problem that fulfill these constraints. However, because we are doing a minimization problem, so we want to focus here on the vertex points, which are going to give you the minimum cost possible. Okay, identify these vertex points. This is going to be point 0, 4. This point is going to be 3, 0. And the middle point, you can make these two equal to each other, solve for the middle point, and you see that coordinates for this one is 1, 2. Okay, now we have 3 points to evaluate. So let's write here, this is vertex and cost in dollars. Okay, let's see. So our 3 points correspond to 0, 4, x and y, 1 and 2, and 3 and 0. Function for the cost is given by the expression. So cost equals 0.9 x plus 0.6 y. This is what we call our objective function, and which is relating to the cost, right? Remember, the cost for each of them here is 90 cents for A and 60 cents. Okay, so when you evaluate this function, you get the total cost for these different mixtures will be $2.4, $2.1, and $2.7. And you can identify that these points correspond to our minimum. This is the minimum possible cost. Okay, that will be the solution. So it will be when you have one x and two y's, or 1 unit of brand A, 2 units of brand B, to making my possible minimum cost of $2.1. Okay, thank you for watching. See you next time.